So we can talk about the mechanisms which refer to the physiology of respiration. And so the first thing that we need to talk about is ventilation. So remember that we need to be able to get oxygen and rich air that's rich in oxygen down to the alveoli in our lungs where gas exchange takes place. And then we need to get rid of that dead air, right? So we need to be able to breathe deeply if necessary, to ventilate, to move the air over the respiratory surface. So in order to do that, we as mammals have a very special mechanism, which is referred to as negative pressure breathing. Amphibians, for example, and reptiles do not have negative pressure breathing. They have to force air into their lungs by gulping air. So they have to do that. So the negative idea about this pressure is that the negative pressure of the lungs is going to automatically draw air in when we inhale. So this is different than, say, when you're on a ventilator, which actually forces air into your lungs, right? So this negative pressure breathing is more efficient because we don't have to use energy to force air into the lungs. And so we can go back and we can talk about what these pressures are. And so the pressure of gases is the movement of the molecules and the forces that they exert. So pressure is due to the movement of molecules. And so in our atmosphere, we have different gases. We have CO2, carbon dioxide, we have oxygen. The most abundant one is actually nitrogen gas, which actually is, we don't exchange nitrogen gas with the atmosphere, but that's actually the most abundant gas in our atmosphere. So all of these air molecules that are bouncing around, all of these atoms are going to exert a pressure. And one of the interesting things is that this pressure depends upon the volume of the container. So as we increase the volume of the container, we're going to decrease the pressure. So hence the negative pressure. So when we inhale, when we have inhalation, we increase the volume of the lungs. And air is automatically drawn in. So let's look at a diagram that shows these differences in pressures. So the atmospheric pressure here is 760 millimeters of mercury. That pressure is due to the different composition of gases in the atmosphere. So if I were to look at my composition of gases in the atmosphere, I would see that most of the gases in the atmosphere are nitrogen, and they exert 597. Oxygen is only about 21% of the atmosphere, so it exerts about 159 millimeters of mercury. So you'll notice that the total atmospheric pressure is 760, but like the percentage has to do with partial pressures. So that has to do with the percentage of a given type of gas in our atmosphere. So this is in the air that we breathe in. This is in the alveoli. So that is the air that is in the alveoli and getting ready to exchange across the respiratory membrane with the capillaries in the lungs. So let's look at this difference in pressure. So we can talk about and we did talk about that pressure in the pleurae as being negative, but we can also talk about the difference between the outside atmospheric pressure and the intrapulmonary pressure. And here, They're just showing that they are the same, that the atmospheric pressure and the inside of the lung are the same. So how do we get a change in the volume of our lungs? When we breathe in, a couple of things happen. So when you take a deep breath in, one of the things is that the diaphragm contracts and it moves down. So it moves inferiorly. So my diaphragm is actually going to flatten out a little bit, and that is going to increase the volume of my lungs. And then I have these external intercostal muscles. These are my rib cage muscles. And when I breathe in, it expands. So I take a deep breath in. I expand my rib cage, the volume, right? So I'm also expanding my lungs. And so that is going to cause air to be automatically drawn into the lungs. And then when I expire, right, when I breathe out, the diaphragm actually relaxes and moves up, and the ribs can actually relax down. I can actually depress them, right? I can actually make my rib cage, if I'm really super trying to breathe, I can depress my rib cage. I can also use my abdominal muscles, right? So I could press in with my belly muscles to get all of the air out of my lungs. So this is the mechanism for ventilation. So let's just write that down. And it's very important to really think about this, because sometimes it appears like when we think about it, we sometimes think about it as being in the opposite. Okay, so let's talk about inhalation. Okay, so inhalation, the diaphragm contracts. It is a weird muscle in that it is domed shaped like this. So when it contracts, it actually kind of goes like this and it moves down, right? So it flattens out and moves down. Okay. The other thing is the external intercostals contract. And the rib cage expands. Okay, all of this functions to increase the volume of the lungs. When this increase in the volume of lungs happens, we have a decrease in pressure, right? So negative pressure inside of the lungs. And this is going to cause air to automatically move in to the lungs. So I think that the confusion sometimes comes in because when I feel like I'm inhaling, I feel like maybe my diaphragm is, I don't know, it just seems like it should be the opposite. Like my diaphragm should relax when I inhale and contract when I exhale, but it's not the way that it works. Okay, so let's look at the other one, exhalation. This is where your diaphragm relaxes. The external intercostals relax. Okay, we get positive pressure in the lungs. So air automatically moves out. Okay, so that would be exhalation. The diaphragm and the rib cage decreasing their volume so that decrease in volume is going to allow the air to move out of the lungs. So that is ventilation, right? If that does not work, if we're not properly ventilating the lungs, we're not getting enough oxygen. And so we might have to be put on a ventilator in order to do that. This is also controlled by the nervous system, right? So some people who have spinal cord damage up in their neck region, that nerve, the phrenic nerve, which goes to your diaphragm, can sometimes not function. And so if you have neck injury, sometimes you become paralyzed and you have to be put on a ventilator to keep the lungs to get oxygen.